Hey guys, this is your first set of notes for completing the square. So this is for 6.8 notes. I don't usually put warm-ups on the notes, but I'm going to put part of today's warm-up on this set of notes because I think it is of vital importance for understanding what we're doing in these notes. So if you'll allow me, I'm going to go backwards and put part of the warm-up on here. So if you don't have this sheet, just write it down on some scratch paper and bear with me. We're going to skip number 1 because it's just a review problem. Number 2 is really where we need to look for today. So this is a problem from Unit 2. We have to find the product and simplify. So we have to simplify this. We have to do parentheses before we can do subtraction, but we can't simplify x minus 1. So we're just going to go to the exponents before we do the subtraction. So we're going to expand this and rewrite it as, that would be x minus 1 times x minus 1 minus 12. So I've just rewritten it in expanded form. Okay, now I can multiply this doing extended distribution by using a box. I'm going to box it up and get my x minus 1 times my x minus 1. Okay, that gives me x squared minus x, another minus x, and then a negative 1 times a negative 1 makes a positive 1. Okay, so that gives me x squared minus 2x plus 1, that's this part, right? And then I have this minus 12. So when I combine the positive 1 and the negative 12, I get a negative 11. So I have x squared minus 2x minus 11. And where that came from is the x squared of x minus 1 squared minus 12. So that pink thing is equal to what we started with, this. It's equal to x minus 1 squared minus 12. These two are the same. They're just equivalent forms. They just look different. Okay, well, that's great. So what I'm hoping that you're noticing when you look at these two compared to the two below it is that this is this, and that this is this. So 4 and 5, these two equations, they are different forms of the same equation. So what I want to know is, can we solve these? So we'll first look at number 4 and see if we can solve it. So we have a trinomial here. We want to see if we can factor it by looking for some magic numbers. Oh, I'm going to see. Oh, maybe not. So we want to see if there are any factors of negative 11 that sum to negative 2. And the factors of negative 11 are 1 and 11. I can make the 11 negative or the 1 negative, but there ain't no way I'm getting a negative 2. So this does not factor. Does not factor. So you might think, does it have solutions? Maybe it's not factorable because it doesn't have any real solutions. Maybe this equation, like y equals something, maybe it's like floating up here and never crosses the x-axis. Well, we're going to look. So if we go to Desmos, and you see I've put in the x squared minus 2x minus 11, okay? You can see it over here. It does cross. It crosses twice. So it has two real roots, one here and one here. They're not pretty. They're real nasty, but they're real. Okay, so we have two real solutions. but I can't find them by factoring. There's no way for me to factor this and use the zero product property. Okay. Whoops. Go back to the note. So solutions, yes. 2 real ones. So let's see if we can figure out this one. Can we solve this one? Remember, these two are the same. They're just in a different form. So let's see if we can solve it when it's in this form. So I want to take the square root of this, but first I need to move the negative 12 over to the other side where it's positive. So I'm going to take this negative 12 and add it over here. Okay, so now I have 12 equals x minus 1 squared. And to undo squaring, I'm going to take the square root. And I don't just want the positive principal root, I want positive and the negative. 12 is not a perfect square, but it has perfect square factors. So inside of 12, we can do 1 and 12. We can do 2 and 6. Those aren't perfect squares. But if I do 3 and 4, 4 is a perfect square. So I'm going to factor this as plus or minus square root of 4 times the square root of 3, and that is equal to x minus 1. I set the x minus 1 free. It's out of the parentheses, it's out of the radical, it's not squared anymore, it's liberated. Now I know that the square root of 4 is 2. So this turns into plus or minus 2 square root of 3 equals x minus 1. Now I want the x alone, so I have to get rid of that negative 1. So I'm going to move the negative 1 to the other side where it turns positive. And that, my friends, is my solution set. Notice they're real, but they're real nasty. Real and nasty. So just because it doesn't factor doesn't necessarily mean that there aren't any solutions. Sometimes they're just gnarly, irrational numbers that are the solutions. So what this brings us to is that in Unit 2, back in the day, we went from this to this. We converted it from this form to this form. That was Unit 2. In Unit 6, we are going to learn a process from changing it to number 4 to number 5. We're going to go this way in Unit 6. And that process is called completing the square. Okay, and it's going to eventually help us solve. Because if we can get it in the right form, we already know how to solve it by taking the square root. We got it made in the shade. We did that on the very first day of solving quadratics. So we just have to get it there. Okay. So that brings us to the notes for completing the square. We need to know that a perfect square, perfect square trinomial, which has 3 terms, comes from squaring a binomial that has 2 terms. Okay, so I have this example here. This is a binomial that's being squared. So this is a squared binomial. And so if I square this, I'm just multiplying by itself. So I'm boxing it. I'm doing extended distribution, multiplying it by itself. So I'm getting x minus 5 times x minus 5. I get x squared, negative 5x, negative 5x again, and then the negative 5 times negative 5 is positive 25. Okay, and then when I combine my like terms and write it in standard form, I get x squared minus 10x plus 25. And this is my perfect square trinomial. 3 terms. Notice that my first term is a perfect square. My last term is a perfect square. It's got a perfect square in the front and a perfect square in the back. Okay? Let's do this one. This one is also a squared binomial. Okay? So, let's do it. Oops, that one's close. I got x plus 7 times itself. That gives me x squared, 7x, another 7x, and then 7 times 7 is positive 49. So when I combine my like terms, the 7x's, and x squared plus 14x plus 49. And that is my perfect square trinomial. Okay, so the big thing about today is that we are going to look for some patterns that we can exploit to go backwards, because we already know how to go from a squared binomial to a perfect square trinomial. We've been doing that since, what, September? Easy, right? We have got to figure out how the heck do we go backwards, right? So we need some patterns to help us out. So the first pattern I want to draw your attention to, you can't see that green, just kidding, so you can see, is the C value. Okay, that's a C, that's a C. Okay, look at those C's. Notice that both of those C's are perfect squares and they are both positive. C is positive in a perfect square trinomial. That's because we have a positive times a positive making a positive, or we have a negative times a negative making a positive. Right? Because the signs match. It's time to look for our next pattern. The next pattern is going to be looking at the B. Okay, here's a B. Here's a B. Right? And while you're looking at the B's, I want you to look at the corresponding squared binomials over here. So if I have a negative 5, then I get a negative 10. I had a positive 7, it gives me a positive 14. The signs match, right? The other thing I want to show you is that if I double 5, I get 10. If I double 7, I get 14. And that's because I have 2 7s and I have 2 negative 5s. They're doubled. I have 2 of each. Okay, so going this way, it's times 2. But remember, in this unit, we want to go backwards. So if we're going backwards from 10 to 5, that's times 1/2, or dividing by 2. So one of the first things that we're going to be doing in completing the square is chopping our B value in half. Okay, so let's talk about that right now. Okay, so completing the square. Completing the square is a technique for making perfect square trinomials. We can use it to solve quadratic equations. We can use it to go from standard form to vertex form. We're not going to do that this year, maybe algebra 2. There are other things you can use it for, but we're going to use it to solve. Our first step is that we chop B in half. So we find the B. In this example, it's 6. And we take 6 and we chop it in half, divide it by 2. And that gives us 3. Okay, the next step, we have to square the result of step 1. Well, the result was 3, so we just squared the 3. And I get a 9. Okay, third step, I replace the C with the result of step 2. So I write x squared plus 6x plus 9. That's my C, that's my B. And I have a beautiful perfect square trinomial. This is a perfect square trinomial. Okay? It's as easy as that. So we're going to practice this 3 times, and then we're going to practice writing square binomials, which is really easy. Purple. Okay, so we take our B. Step 1, we chop it in half. Half of 16 is 8. Then we square it. 8 squared is 64, and replace C with 64. Done. Next one. We take negative 4, chop it in half. We get negative 2. Then we square that. Negative 2 squared is positive 4. Replace the C. Done. You like this? This is like as good as it gets, guys. We take a negative 8. That was a B. We take negative 8, the B. We chop it in half. Okay? Oh, negative 8 chopped in half is negative 4. Okay, we square that. We get 16. Each of these, each time we've made a perfect square trinomial by completing the square. Okay, let's do example 5. I'm going to do example 5 with you, and then we're going to look for a pattern. And then then you can be done. You can stop the video. If you want to do number 6, you can, but you don't have to. Okay. Step 1, write the C value that completes the square. So we take the B, we chop it in half, we get a 4. We square the 4, we get 16. Step 2 tells us that we have to factor the perfect square trinomial. So we know how to factor. We've been doing this for like over a week. So we find factors of 16, put sum to 8, right? Our C and our B. Right? Well, guys, I'm feeling 1 times 16, 2, 8, 4, 4. Woo, 4 and 4 look good. Okay, so this factors as x plus 4 times x plus 4. Now, for the last step, I'll give you a hint. If I have 5 times 5, isn't that just 5 squared? Yeah, so that's what we're going to do. Instead of writing it as x plus 4 times x plus 4, we're writing it as x plus 4 squared. Now we're done. Okay. Next one, take your B. Chop it in half. Half of negative 6 is negative 3. Square it. You get a 9. Okay, now we factor the perfect square trinomial. So we want factors of 9 that sum to negative 6. So 1 and 9, 3 and 3. I'm feeling the 3s, but I need to make them both negative. Boop, boop. And then I get x minus 3 times x minus 3. Now I write it as a squared binomial, which would be x minus 3. Okay, number 3. I take my B, chop it in half. Half of negative 2 is negative 1. Square it. I get a positive 1. Factors of 1 that sum to negative 2, because I have to factor the perfect square trinomial. So 1 and 1, they both need to be negative. And I get x minus 1 times x minus 1. And then that, as a squared binomial, is x minus 1 squared. Okay, it's pattern time. Okay, here's your pattern. See it? There it is. It's the same number over and over again, right? Look at this. 4, 4, 4. It's the same number, okay? So some of you are going to love this because you can see a massive shortcut. And the other half of you are going to love this because it's easy and you already know how to factor this stuff, okay? So you can love it because it's a shortcut, or you can love it because you don't have to learn anything new. You just rattle through what you already know. But today is an easy day. You're welcome. I am going to do example 6, just in case I'm not as clever as I thought I was and you need another example. But if you get it after example 5, you can stop the video and work on your assignment. So you can stop me now. You don't have to watch this part if you don't want to. Okay. All right. We take 14, chop it in half, we get 7. Square 7, we get 49. Okay, we look for factors of 49 that sum to 14, and it's 7 and 7. Right? It's got to be 7. So then it's x plus 7 times x plus 7. That gives us x plus 7 squared. Excellent. We take our 20, our b, chop it in half. Okay, we get a 10. We square it. We get a 100. Woo! Factors of 100 that sum to 20. 100. 20. Guys, I'm feeling 10 and 10. Okay? It's got to be x plus 10 times x plus 10, which is x plus 10 squared. All right, last one. Take your b, chop it in half. Half of negative 10 is negative 5. Square it. You get 25. Now we need factors of 25 that sum to negative 10. I'm feeling 5 and 5, but make them both negative. Okay, that gives me x minus 5 times x minus 5, which is x minus 5. Okay, hopefully that helped. If not, come see me for questions, or even if it did help and you have questions, you can still come see me. I love a visit.